All right, we're doing this because we are doing this, and that's just that. Can you trust an AI press release? So we just got done having O1 get released. Let's see what we got here. Of course not. Here's how leading AI lab misleading customers, journalists, and each other. All right. By the way, obviously, I'm going to read this article. We've already talked about this. If I have a chance to read something in which clearly confirms my bias, I'm going to read it. Every single time. Everybody knows this. Every month or two, an AI lab releases a new model that they claim leaves most, if not all, of their competitors in the dust. Recent examples include OpenAI's GPT-4o, Anthropic's Claude 3 Opus, and Google's DeepMind Gemini Ultra. These announcements are generally followed by a large amount of hype from the tech media. Like Ars Technica's Breathless, the AI wars heat up with Claude 3 claimed to have near-human abilities. Really? I didn't realize that they claimed near human abilities. No model has beaten GPT-4 on a range of wide. Like, now that I'm rereading it, this is actually pretty crazy. I didn't realize how nonsense these things near human could mean anything. It's near human. I mean, if you really think about it, a lobster is actually near human theoretically. I mean, percentage of genes is wildly similar, on the grand scale of things. People tend to take these claims seriously. They use these numbers to decide which labs are ahead of the others and often decide which LLMs to use. However, they would do better to treat these reports with a healthy dose of skepticism. Consider Anthropic's Claude 3 Opus, the largest in the Claude 3 family of models. Now they have Claude 3.5, right? So 3.5 is even better. The model's release announcement claims that it exhibits near-human levels of comprehension and fluency on complex tasks, leading to the frontier of general intelligence. Opus scores 86.8% compared to GPT-4's 86.4% on the massive multitask language understanding benchmark, a set of about 16,000 multiple-choice questions across 57 academic subjects commonly used to evaluate large language models. With the other benchmarks, dude, imagine training your model on these 16,000 questions so that you can get a high score on these 16,000 questions. Isn't there an inherently bad idea here? Can we all agree there's something about this that is just, is this Obama giving Obama a medal? And the worst part about it all, bro's only 86% correct. You gotta just take a second and just take a step back and go, how funny is that they're putting the medal on themselves while cheating ineffectively. They're getting a B, not even a B plus. That's so good. It's so good. With other benchmarks, the difference is even starker. 50% for GPT-4 and 37% on GPQA, a test of graduate level reasoning. 84.9% on GPT-4's, 67% on human eval, a measure of coding ability, and 60.1% to GPT's 4, 52.9% on math, exactly what you'd expect. Many took this to mean that Claude 3 Opus was significantly better than what was then the live version of GPT-4. However, the numbers that Anthropic used for GPT-4's performance came from OpenAI's March 2023 release blog about the original public GPT-4 model, GPT-4 o3.14, and not then current GPT-4 Turbo variants. All right. It wasn't unreasonable for Anthropic to use the numbers from GPT-4 releases in their own report. The report even includes a footnote with the caveat that some of Microsoft researchers claimed higher performance numbers for GPT-4, perhaps due to better designed prompts. But when I looked at the source code used by the team at Microsoft, I was able to determine that they did no fancy prompting for these evals. They just used GPT-4 Turbo. Nice. They just used something newer. In fact, when we compare Opus with the later models, we see that GPT-4 Turbo performs better than Cloud on more than half of the benchmarks where both evaluated and is competitive on the rest. In this case, the mistake is small. From the subject experience using all of these models, the conclusion that Claude 3 is slightly better than any model in the GPT-4 family at the time of release seems to be true. Claude 3 is indeed competitive with GPT-4 on most tasks, and I found it better for coding assistance and creative writing. The difference in benchmark performance between the model is small and doesn't seem to reflect user experience. But there are other press releases that are substantially more misleading. It is shocking. I can't believe, my biggest takeaway right now is the ultra seriousness of these previous models, and then afterwards, how they talk about the next models being just drastically better. How funny is that that you read this and now we laugh at that? Oh, well, look at that. It's actually near human is ridiculous because now these new ones are even better. It's like each iPhone release. It's like an iPhone release over and over again. Take the Google press release on the original 54B Palm model. The post claims that Palm outperforms all publicly available models on many natural language processing tasks. However, it's now generally believed that Palm is the worse than the earlier GPT 3.5, specifically the model called Code DaVinci 002 for most use cases. One important reason is that Palm seems substantially worse when used with chain of thought, a prompting technique that helps language models break down questions into intermediate steps. Chain of thought prompting typically improves models' performance, but not for Palm, which often did worse when given a chain of thought prompt with the direct querying. So native trusting the press release would cause readers to come to the wrong conclusion. Nice. Thoughts be wilding. So, I mean, is the big takeaway here that never trust press releases? Is that it? Is that it? Is that it? Is there anything else? Be more skeptical. I genuinely feel bad because so many people are absolutely freaked out about the future. I mean, we've even had multiple questions today about, I'm new into coding. Should I keep on going due to AI? It's just like these press releases just say wild stuff, and then they're even like testing against each other that are further in the back, and then it's just like, yeah, I thought so, right? The other big takeaway is that I have near Michael Jordan basketball performance. It's true and factual. There are people losing their jobs right now because management believes this shit, man. Yes, exactly. See, that's the real takeaway, is that we laugh at it because it is a little ridiculous. Like, sure, LLMs have a lot of great things that they can do that is kind of fun, but it is completely ridiculous that there are actual people that are losing actual jobs because people are believing the crap. There are lots of similar tricks that AI companies use to skew their model reports. Before we dig into them, though, here's a few caveats. First, exaggerated claims are not necessarily the result of deliberate deception. Knowing the performance of models is genuinely difficult. That's fair. This is especially true with OpenAI models, which, as we've seen, often get stealth updates without much fanfare or additional benchmark numbers. Second, applying an appropriate degree of skepticism doesn't mean entirely ignoring the contents of the press release. Obviously, doing well on benchmarks is positive evidence of the quality of the model. When the gaps in the benchmark performance between models are large, it's reasonable to believe that there are higher performing models is better. Okay, that's fair too. However, small differences in benchmark performances are often outweighed by considerations such as methodological differences, selective reporting, and limitation of the test themselves. You see this all the time with any sort of reporting. You'll notice that they switch what they're reporting specifically because it's easier to say, oh, look, we're doing really good in this thing. And then when something else comes out that they're losing at, they just kind of ignore that one thing. I said this is a very, very common technique, is you only report the things in which you highlight about, in which you're just doing awesome. So why are headline benchmarks misleading? Absent outright fraud, which is rare, or training on the evaluation data sets, there are four main reasons. Well, I mean, I guess we should probably determine what is fraud. Is not, like, real talk is not saying a number that you know is negative fraud. Withholding important information, is that fraud? I know it's lying by omission. To me, I don't think it technically falls under the fraud category, in the sense that you're not selling a house. Therefore, if you had a large known disaster within the house, if you lie then it is actually considered fraud. But not reporting all the statistics, just reporting on some of the statistics, I'm not sure if that's considered fraud. Unethical, but not fraudulent. Yeah, I think it just depends on what you're selling. Since you're not selling, if you're an investor, I think so. Yeah, so if you're an investor, it's a much different situation. It makes the data fraudulent. Immoral, like Zig. Kind of depends. If you do statistical analysis and you leave out data to skew the results, that is fraud in the science, for instance. True. But if you only report the ones in which you did not manipulate any data or remove statistical outliers, Apple does the 5x faster than previous generation. Yeah, so for those that don't know, Apple does this, and they will like skip generations in which they're actually comparing to. So for those that don't know, the M4 chip was not compared against the M3 chip. It was compared against the M2 chip. And so it's like 50% faster, and you're like, wow, these are crazy numbers. But then in the little teeny tiny little asterisk, it was like compared against the M2 chip. Yeah, they always skip one. I know, but doesn't that feel kind of shitty? Economics of attention, yeah. I mean, that's the problem is that, I don't know, for me, leaving out benchmarks in which makes you look worse and only leaving in the ones that make you look good to give the impression that you win on all sides, I would say should be considered fraud. I don't see how it's any different than reporting the problems of, say, selling a piece of property to somebody, but leaving out the worst ones, but leaving in the ones that won't make the sale fall through. To me, I don't see how it's any different. LLM developers have dozens of possible benchmarks to choose from. The easiest way to make their model look good is to focus only on the benchmarks where the model performs better than the competition. These days, it's quite rare for the labs not to evaluate new frontier models on standard benchmarks like MMLU. But it's also very common for companies to emphasize bespoke in-house benchmarks on performance on the very narrow subset of tasks that their model performs well on. The specific way models are evaluated can also affect their benchmark performance substantially. We've already seen that chain of thought usually improves models' performance. So does prompting the model with an example of correct question-answer pairs, called in-context examples. But in reports, some models are evaluated with chain of thought while others aren't. Oh, that seems kind of wild. So they're not even training on the same items. They're actually training on different styles and then reporting a win in one but not the other. That feels pretty broken. The number of in-context examples is often different, and the prompts are almost always different. As demonstrated in many prompting papers, the exact way in which you elicit capabilities from a model can greatly affect what numbers they get on the benchmark. That does not feel good. I just always took the numbers, meaning that they took the same prompts with the same information, and they went against each other, and they're like, here you go. This is how much better we are. But if they're actually using different like prompting techniques, let alone different examples, let alone the amount of examples, that feels like actual. That just feels like fraud. That feels like cheating. The blog post accompanying OpenAI's GPT-4o release uses both of these tricks. In it, researchers compare the MMLU performance of 4o using chain of thought to the performance of other models, all of which were evaluated without chain of thought. For those that don't understand what chain of thought is, you can greatly improve the performance of your model. We've even seen it. Just me doing a little experiment with Claude Sonnet. By what I did with my experiment is I have a unit test and I asked it to write code to fulfill this unit test. When the unit test breaks, I take the error from the output of say Vite or whatever language, and then or whatever framework, and then pipe it back in with the unit test and say fix it. If I just do that, it rarely can fix the problems. But if I ask instead, here's the unit test, here's the broken code and the error, could you please tell me what went wrong and how you would fix it? Then take that output and pipe it back in, it does dramatically better. So in other words, I'm helping the model think for itself by taking step by step. You're basically priming it into the right direction. Yeah, you're giving it effectively like a two-step process to solving something. Like, I mean, and when I mean that, I mean like, look at that. So I literally run the code generation test, run the test, I print out the results so I can see them, and then I run reasoning. And I make it do that over and over again, so that way I can force the model to consider the right idea. This is actually hilarious. This is like Warhammer 40K machine spirit rituals. It is. It's actually we are actually approaching the Warhammer 40K, just worship the machines and do the rituals because we don't know how they work. Oh no, that's fucked. It is. With chain of thought, GPT-4o scores 88.7% on MMLU, but when evaluated using the same methods used for all other models, 4o scores only 87.2. I mean, better, but I mean, it's not. I mean, that's not drastically different. To their credit, their caption does clarify that they use chain of thought, but it obscures the fact that the other models were all evaluated without it. It seems likely that OpenAI highlighted the 88.7% number because it suggested a larger improvement over their competitor models. Really shocking. The same blog post also includes only 6 out of 10 standard benchmarks that Anthropic included in Claude 3 release blog post and a different subset of those in GPT-4 release. One wonders if the reason for this is that 4o performs worse than Opus on unreported benchmarks. One would probably say yes. Bro's cooking with that thought? Oh, yeah. Models improve over time, and interesting claims are generally about model families. Labels like GPT-4 or BARD really refer to a family of models. These families are rarely static. Generally, companies continue training their models over time and update their APIs or UIs accordingly. As we've seen, GPT-4 1106 is better than the original GPT-4 0314. which in turn is better than GPT-4 early on almost any standard benchmark. And despite both Code DaVinci 002 and Code DaVinci GPT-3 models, Code DaVinci 002 is much better than DaVinci on all benchmarks. Sometimes we see the opposite when companies choose cost over capabilities, replacing more capable models with versions that are cheaper and faster to run. All right, fair. All these changes make it difficult for outsiders, even researchers at other labs, to pick the right comparators for their models. Even if you wanted to test your model against a non-turbo GPT 3.5 model, such as Code DaVinci 02, there's no way for external researchers to do so. Oh, okay, so that does make it hard. I guess, yeah, that's one thing that does make it pretty hard, is that if you don't have the exact test scenario of these other companies, then you don't know the exact, like, you can't replicate it one for one. I still think the whole chain of thought versus not chain of thought thing, though, is kind of weak, though. I must say that feels kind of scummy. Headline numbers hide important differences. Returning to the Google Palm releases, GPT 3.5, or more specifically Code DaVinci 002, scores 65% on MMLU, while Palm variant gets 69.6. Nice. And Palindrome, double nice. But this doesn't mean that Palm is better across the board. In fact, the two models do well on different kinds of tasks. Palm broadly outperforms Code DaVinci 002 on most categories except coding and math, where Code DaVinci 002 is substantially better. However, it turns out that coding ability is a strong indicator of being usable with chain of thought prompting and arguably being good at reasoning in general. Writing software is also economically valuable for most people in ways that, say, memorizing historical facts is not. Fair. Double nice, fair. This not only meant that there was an easy way to improve Code DaVinci 002, give it a scratch pad and let it break down the question into steps. It also meant that Code DaVinci 002 was more directly useful. For example, I started using Code DaVinci to help me write research code. Okay, nice. Also kind of scary. I'm not going to lie. The idea of using models to write research code can be a little bit scary to me. Long as we're really making sure that there's no problems in the research itself, okay? Research code is the scariest code of all time to write because you're basing ideas off that idea. It scares me a little bit. Another example could be found in OpenAI's dangerous capability evaluation. After GPT-4, the company wanted to test if the new model could help users design dangerous bioweapons. They broke the task down into 5 different subcomponents: ideation, coming up with concepts for new threats; acquisition, obtaining materials; magnification, growing the agent; formulation, and preparing the agent for release; and finally, release. They also divided participants into 2 groups, experts and students. Indeed, access to GPT-4 improved students' performance at 3 of 5 of the component tasks and improved expert performance at all of them. Let's go bioweapons, huh? All right, you can bioweapon these nuts in your mouth. Damn, that's crazy. Adding together these cumulative improvements produced a statistically significant effect. GPT-4 makes it easier for people who already have some expertise to develop bioweapons. Nice. Also terrifying. But nice. But that's not the only, but that's not the result OpenAI reported. Instead of adding together the results for different components, which you'd expect since all the parts of the same task, since they're all part of the same task, they chose to treat them as independent tests. When you're testing more than one hypothesis in the same experiment, it's more likely that any of them, purely by chance, will yield false positive results. To combat this, statisticians typically apply an adjustment. For every independent hypothesis, they'll set a higher bar for considering their results statistically significant. In this case, OpenAI used a correction that their test results as if each of the 5 subtasks was different. Unrelated tests, setting the bar for statistical significance 5 times higher than it would be otherwise. OpenAI was really measuring only one thing: whether the model helped participants complete the full task, including all necessary components. Looking at the task holistically, it did. But with the adjustment in place, they found and reported that GPT-4 had no statistical significant impact on the participants' ability to design bioweapons. Oh. I see. Okay. So, for those that didn't catch what this was saying, this was quite the wordy amount of stuff that was said here. But effectively, what it was saying was that in an example, students were able to get 60% of the way there to creating bioweapons, and experts were able to get 100% of the way there. But by combining all the data and then making the entirety of the task the requirement, it shows no statistical improvement beyond the previous models because most of the failure was compounding. Sneaky. Oh, yeah. So we got to pass that through the BS filter. Where's my BS filter? All right, here we go. Let's pass this through an AI BS filter. Let's see what the AI BS filter has to say about this. All right. Remove the bullshit. Well, there you go, everybody. That's the bullshit removed, is just that. That whole sentence, we could have taken all this 150 words and reduced it down to a singular word. Bullshit. That was pretty good. Benchmarks generally don't measure the things we actually care about. Fundamentally, we don't care if an LLM knows a lot of U.S. history or can do 8th grade math. These test scores matter only if we can use them as a measure of general competence or economic value. While we can use benchmarks to get a general sense of how good models are, it'd be surprising if a human-level AI could do 8th grade math. It'd be surprising if a human-level AI could not do 8th grade math. By the way, I actually find 8th grade math to be very important because it doesn't seem to be able to do 1st grade math. You'll get all sorts of crazy results once you start doing math. And so for me, it actually seems really important that they actually have reading, writing, and arithmetic properly in. The correlation between scores and real-world performance isn't strong enough that differences of less than 1% on benchmarks are meaningful. Yeah, I mean, I think this is the big win here, is that your day job and doing things like, unless if you're I hate the shit on certain fields of computing. But if you're just building CRUD applications, I can imagine that AIs are significantly more helpful because what you're doing is not necessarily all that revolutionary. You're just going, hey, database, do you have this? Apply a couple of additions to the old-fashioned business logic, call that a day and ship it down. 200, right? It's just a common pattern. There's not a lot. Like it can produce a to-do app really, really well. I need CRUD AI. Exactly. It's just CRUD AI. It's fairly a solved problem, and the maneuvering within that problem is really, really tiny. So I can actually see that I can see why people love Copilot, because it really allows somebody who's moving already okay fast move much faster because they have very little they need to actually rely on. They can just spin through stuff very, very fast. And so I understand why some people find, I think that's the disconnect. And I'm not trying to demean the person that's building that. Hey, you know what? I want you to know this right now. If you right now are building web apps that are just simple stuff and you're using AI and you're actually running and moving fast and you're enjoying it, and at the end of the day, it allows you to get more work done, and you're still getting that bag and you're still having a nice time, you know what? Go for it. Damn, I'm doing that right now. Hell yeah, brother. Right? Like, if that's what you're doing and the AIs help you, I think that's fine. Right? Yeah, I think a lot of Level IO stuff is just CRUD, and he's doing well. Dude, you can literally earn millions of dollars just doing CRUD stuff. And I think that that's why there's such a disconnect, is that some people are building things that I think make it fundamentally hard to use Copilot for, and some things that are fundamentally easy for using Copilot for. And then there's just this huge disconnect. Right? Copilot for doing little PHP like administrative web portals is awesome. So much faster when building out lists of columns and loading data. Yeah, I'm sure it's great. I'm sure it's great, right? Prime, I wish you to do a couple days on Coder and give feedback. I might do it. You never know. I might do it. I've been wanting to do a full development cycle only using AI. Like, actually try to use as little of me programming as possible, and seeing if I can do that. Especially if the models already do quite well. Claude 3 Opus getting 86.8% on MMLU instead of GPT-4's 86.4%, or GPT-4o's 87.2% instead of Opus's 68 or 86.8%, probably doesn't mean very much. Yeah, this means effectively nothing for us. Part of this is that benchmarks must be simple enough that they're both easily reproducible and sufficiently easy to run. Standard benchmarks tend to use multiple choice questions because they're easy to evaluate, even though many models use cases involve free-form generation. Even the most realistic coding benchmarks, such as SWE Bench, test the ability of language models to write code using unit tests, have limited scope, and don't test for qualitative factors like code style. Again, any benchmark that's available is a benchmark in which can be used to manipulate. Like, that is something that you must understand. And so when I see this, the only thing I see is, how much do you want to bet that these things are being manipulated? Right? So even when these models do better, they're doing better on things they've already been specifically trained at doing. In cases where performance is generally similar, scoring worse on benchmarks might even indicate that the model is better. OpenAI's InstructGPT paper notes that instruction fine-tuning, training an existing model on a database of matching prompts and outputs to improve its performance at a particular task made the model do worse on benchmarks, even though humans preferred its responses. This is such an amazing statement right here. All of the improvements actually weren't making real life things good. That's awesome. And this makes sense, right? You would assume that if you kind of make something kind of get tuned to a very specific set of reporting, it may become worse at other sets. I mean, that seems reasonable. Models that use a lot of capacity on memorizing facts may perform well on benchmarks in a way that doesn't matter for users, while fine-tuning the models to be pleasant conversational partners may cause them to forget some of the knowledge that enables them to do well on benchmarks. So, like God? Is this friend mention? Friend mention? It's actually God? Being appropriately skeptical. With all this in mind, can you really tell if one LLM is better than another? Use the benchmarks as reference, not as definitive evidence. Benchmarks are helpful for getting general sense of model capability, but small differences don't mean much. Look at specific claims that the evidence actually supports. While headline claims are often misleading, specific claims about benchmark performance are almost always correct. By noticing what specific benchmarks are cited in the press release, which specific comparison models it lists, and which specific evaluation methods were used to get the benchmark numbers, you can get a much better sense of what the evidence does and does not support. Also, do not read tech media headlines, like ever. Nice. I have been disappointed by a lot of tech media headlines. This is good. This is very, very good. Just period. Ever. The end. Don't do that. Joke's on you. I don't ever read. That's why I read to you. Focus on the uses you care about. If you're deciding which language model to incorporate into your workflow, I'd recommend looking for evidence about the specific tasks you want the model to perform. Ideally, you would test the language model yourself on a task you wanted to use it for. You could even keep a standard set of representative problems that current models cannot help you with, and then test new model releases on that set. When that is infeasible, I'd recommend looking for evaluations or benchmarks more analogous to your use cases. I mean, to me, it just seems like if you want to use models for your stuff, just actually explore each one of them. That's all I'm hearing. And the thing is that it kind of feels like you have to explore each one of them, and then once a month you need to re-explore every one of them because things change so fast that at the time of you making a decision, well, once was good, now is bad. Like you see that with GPT-4, right? GPT-4 was really different in the beginning than it is toward the end. It just started getting like pissy. For me to make it produce code just got annoyingly difficult. I had to keep being like, no, actually make the code now, please. All of this requires much more effort than reading a press release. Unfortunately, there is no easy way for consumers or independent researchers to compare cutting-edge models. Be skeptical and be prepared to do your homework. I mean, you can kind of test cutting-edge models. The ones that they have publicly available, you can do your own bespoke test. To me, that's the only way to really come up with a good way to know if you like what you like, which is you just have to have your own bespoke test that meets your own needs. And if it works better, then you say, hey, this one is better for this task specifically for me and my ability to do prompting. Because I assume also that prompting is fundamentally different across the board. Like you can't use the exact same prompt for each one because you may accidentally find one that performs the best on one prompt, and then you'll accidentally do that. Copilot is still GPT 3.5, and I'm shocked anyone still uses it. Is that true? I thought Copilot X or whatever was newer. I assume it's really 3.5. Oh, yeah. I mean, this makes sense. I mean, I get that. This is where I say it probably just makes sense. If you don't know what you're doing, I assume these copilots and stuff can be really good. Have you heard of Copilot DN? These nuts got up. Oh, these nuts right on the face. Nice try. Burbana, more like Burbana, these nuts. Something, your face, and also all that other stuff. Shut up, Prime. Did he finish the video? I didn't hear the name. The name. Okay, the name. The name is... I guess what I didn't realize is that they were actually not only testing models differently, but a lot of these things don't even matter. But even when they're testing models differently, having chain of thought versus not chain of thought leading to different results kind of seems a little bit yucky and not specifically. It should be probably called out. And also, this whole sentence breaks down to this right here. Bullshit. All right. Hey, the name is that's probably just bullshit. A gen.